Let's add some physics to our 2D game here in Unreal Engine. Now, Unreal isn't necessarily an engine known for dealing with large-scale physics all the best. It's not horrible at it, but there's definitely engines that deal with large-scale physics better, especially if you do it in 2D, because Unreal does do all your physics calculations in 3D, which on a scaled up size does start adding up. But we can very much constrain our physics to being on a 2D plane, which means that we can have 2D physics objects, which is quite cool. So as we've discussed in the past, if I go here and I show the collision of all my 2D objects has depth. This is the depth of the collision of these objects. So they will be able to interface with any other 3D objects or even other like sprites that have thickness to them as well with physics. So let's make a quick physics object. And I'm going to do this fairly easily to start with just a cube. I'm going to set this cube to being on y equals 0. I'm going to set the cast shadow to being false because I think it's ugly. And we're going to just simulate physics. So if I just turn on simulate physics, we will see something happen surely, and that is it falls down, and then when I like jump around and push it around, it just flew off. That's not what we want, is it? No. So what we do instead is let's just open up this details panel a little bit more. In the physics, we can constrain this to look on a certain location and rotation. It also has a couple of modes, which are effectively like presets. We want to look this on the X and Z plane. So if we do that, you will see that it no longer does any weird stuff. Well, now it's gone. It no longer does any weird stuff in the depth, so it doesn't rotate toward the depth, it doesn't move toward the depth. It now is just a 2D physics object. It only does physics in the same axis that everything else in the game exists. So that is basically how you set up 2D physics for your objects. Now, of course, this is just in a single actor kind of way, but we can set this up in a blueprint class as well. So let's do this as an actor. Let's call this physics. It's very badly misspelled, but sure. Such as this little tree trunk. I kind of like that. So let's make that into a sprite. And we can use some of these things here to edit this a bit. Because right now there's a lot of empty space above this and we don't want that. So let's add it to source region. And we can start like pulling this around a little and moving this around a little bit to make this a slightly like tighter fit around it. So that it actually like reflects it. Then we can edit the collision if you want to. And by default, it's just going to be using a box. I don't want to do that. So let's go down here. We have some collision settings. So in the collision geometry type, I'm going to set this to fully custom. Delete the collision shapes, and I'm going to draw my own polygon around it instead, so that it actually will react quite accurately in the world to the shape that it is, because it's going to be a physics object. It needs to be like at least semi-accurate to the way that it is shaped. Not massively so, but like at least something a little like this. We have like one little vert that's in a weird place, but sure. Well, let's move some of this around a little more, so that it really like lines up properly with the shape. Now, we have this shape in place, so we can go back into our physics actor, where I've added a paper sprite component, which you can just do by going in here and typing sprite, paper sprite, there we go. And that will be our little tree trunk. I think our tree trunk also needs to have a pixels per unit of about 0.2. And then in here, we can effectively just do the same thing. So we select the actor as a whole. So then we can go down, we can simulate the physics, make sure that it's constrained to, in our case, the X and Z plane. And that's kind of all there is to it. So now if I add this to the world, we have a more properly like 2D object, which should be at y equals 0. That will also adhere somewhat to the shape that is actually in. So let's see how that works. There we go. Properly 2D physics object. Now, Now, of course, this still does look a little bit on the weird side, the way that it moves around, because it can like rotate around and things that old pixel art games couldn't do with their sprites. So that is a little bit uncanny, in my opinion, with pixel art. But we have 2D objects that fully have like their 2D physics, which again, it actually is 3D physics. It's just constraining it to the X and Z plane. So if you have like 1,000 of these objects all interacting with each other and stuff like that, it's going to more quickly slow down than an engine that actually does the physics for 2D objects in only 2D. And a very big thank you to all my Patreons. You can see them on screen right now. If you want to help support the channel or get any of the project files in any of my tutorials, there's a link down below to the Patreon page to support me, or alternatively as a YouTube member. And of course, an extra massive thank you to my Cave Digger tier supporters, Sir J. Thomas,